Welcome to MIT Compass, thinking and talking about being human, a show about exploring fundamental questions.
What do we value and why?
What do we know, and how do we know it?
What do we owe to each other?
Hosted by MIT professors from across the humanities, arts, and social sciences, each episode takes on the moral and ethical questions of the human experience.
This week, we'll be talking about truth and knowledge. I'm Alex Byrne from the Department of Linguistics and Philosophy. With me are three other MIT faculty members. First, Professor Anne McCants.
I'm Anne McCants, and I'm an economic historian of the late Middle Ages and early modern Europe. And I also direct a program here at MIT called Concourse. It's for first-year students, and our goal is to embed the science General Institute requirements in a context of social and humanistic study.
Thanks, Anne. Next is Professor Pekka Hosoi.
Hi, I'm Pekka Hosoi in Mechanical Engineering and Mathematics. I also have an appointment in IDSS, which is the Institute for Data Systems and Society. My research focuses on fluid mechanics. I've worked on soft robotics, and most recently I've gotten interested in biomechanics and sports.
Thanks, Pekka. And last, Professor Jim DiCarlo.
Thanks, Alex. I am a professor in the Department of Brain and Cognitive Sciences. My lab works on vision in non-human primates and building models of visual processing that apply to both monkeys and humans. And I also am the director of the MIT Quest for Intelligence, which aims to discover an engineered level understanding of human intelligence with impacts on human health and in future artificial intelligence.
Thanks, Jim. And thanks again to all three of you for making the time to do this. So we're going to have a chat about truth and knowledge, and let's start with truth. So the MIT values statement mentions the pursuit of truth, or perhaps the quest for truth would have done equally well, as something worth valuing. So I thought I'd begin with a deceptively simple and probably unfair question. What is truth? Perhaps there's no easy answer, but if you had to answer in a sentence or two, what would you say? And do you want to have a stab?
Sure, Alex. I think that this question is so fundamental precisely because it cannot be answered once and for all people from all perspectives. But if you come at it from, let's say, a theological perspective, I think it has, historically, it has been answered from that perspective as being the transcendental reality, if you will, that is out there, that is beyond us. So that's one way that many people have thought about what truth is. Something outside of ourselves that really exists, even if our ability to access it is limited.
Yeah, I'll build on what Anne said. So I like her framing of something that exists outside of ourselves. I think, putting my engineering hat on, I think table stakes is that it has to be something that is supported by empirical evidence. Like Anne said, that's not something that is an absolute, because the way we interpret empirical evidence shifts as we learn more or as time progresses. But I like this idea of something that is in some way absolute beyond our perceptions.
Excellent. Jim?
I agree completely with Anne and Pekka about being outside of us. I would think of it as something that's in the limit that we will never actually achieve, but it's an aspiration. And so I think we'd shift the conversation again, maybe thinking also as engineer from truth towards utility and how we seek truth to actually gain utility. But truth is the aspiration, which we never actually achieve.
Okay, excellent. Right. So there is a sort of common theme that truth is an ideal or an aspiration, and perhaps we'll never reach it. You can pursue a rabbit but never catch it. And similarly, the idea seems to be you can, indeed we should pursue truth, but that doesn't mean we'll ever find it. But what do you think of the sort of flat-footed response that surely we can all agree that it's sunny today? But then, assuming you agree with that, you wouldn't disagree with the addition that it's true that it's sunny today. Right? I mean, if Anne said, it's sunny today, and I said, Anne, that's true, it's not that you, Pecco, and you, Jim, would be saying, oh, well, that's a terrible mistake because, Anne's assertion was fine. But when Alex followed it up with, that's true, that was really overreaching because truth is this aspirational thing that we can only aim to but never actually reach.
Alex, I think you're pushing our linguistic strings a little bit here. The form in which you use true, right? The casual conversational, Anne made an observation, Alex said, yeah, I think that's true. What you're really saying is that's how I see the situation as well. I look up in the sky. I don't see clouds. The sun is out. It's a sunny day. And I think that kind of true and the truth you asked us about at the outset they are semantically related, but they are not the same thing.
So there's kind of truth with a little t and truth with a capital T, and
that's more or less how I operate.
Yeah, I mean, so if we were 2,000 years ago and somebody went outside and said, "Hey, the sun goes around the Earth," somebody else would say, "Yeah, that seems true. Yeah, that's what it looks like to me." Right? So there is sort of an acknowledged agreement between those two people, but it's not related to what actually happens between the sun and the Earth.
Right. Or I was going to say that's true, but maybe I shouldn't. But of course, in your envisaged example, the first person was incorrect, saying that the sun goes around the Earth. And so because of that, when the second person said that's true, that was just another mistake.
Correct. Yeah. Actually, I want to second what Jim said early about the utilitarian value of getting close to truth. There's the famous quote that all models are wrong, but some are useful. Right. And so I think when we make those models, we are trying to uncover something fundamental and something that gives us predictive power. And sort of the more accurate or the more predictive those models are, so they enable us to become better decision makers. I think that's sort of the direction of, I'm putting air quotes now, truth in engineering.
That's exactly right. That's the George Box quote. And as you say, you approximate it. The models lead to predictive power. The models try to embody our current statement of truth, but the models also accept that they're not yet true if we take them seriously. And to push on your point about who's wrong about the Earth being, we actually don't know. Right now, the evidence suggests, if you take it at its limit, right now, the evidence suggests that the planets are rotating around the sun. But if you really push the limit, we can't prove that. Right. So again, that sounds odd, but this is really pushing against the notion of you never actually get to absolute truth. But it's more utilitarian to accept the second view for the moment. It makes better predictions. So we're going to go with that for now.
Okay. Well, shall we segue to knowledge? We've been talking about truth and reaching the truth or finding something out, discovering that the butler committed the murder seems to be coming to know that the butler did it. So just bracketing Jim's skepticism about whether we can actually know anything for the moment, let's begin with the MIT mission statement, which perhaps should be read as aspirational rather than as a claim of about what MIT actually does. The mission of MIT is to advance knowledge and educate students in science, technology, and other areas of scholarship that will best serve the nation and the world in the 21st century. So the mission is advancing knowledge and also preserving and disseminating knowledge. And so, Jim, consistent with your view about knowledge being aspirational, you could still say that, well, we are a massive improvement over Aristotle as far as getting close to the truth goes, because our theories are much closer to the truth than Aristotle's, or just putting it entirely pragmatically, our theories are much more useful than Aristotle's. They enable us to do things that Aristotle's theories didn't.
I agree. And I liked how you put the word, again, it's not more, they're more predictive. They're more useful.
Yeah,
right. That doesn't make them right. It also doesn't make the other ones wrong. Back to Anne's point, they were just less predictive and less useful. right? So I think getting away from these black and white notions of right and wrong is part of the challenge here for students and for scientists, right? Like, you discovered oxygen. No, we have a better model that includes this thing that we call oxygen at the moment. That sounds odd, but that's actually at the core what's going on, right? And it's just we're taught, of course there's oxygen. Well, for a while, of course, there was phlogiston, right? That doesn't make these things, you can't accept the permanence of all of that. And that makes life feel unstable a little bit. But if you just think of it, this is our current belief system, and here's how well it can do. And it will evolve in ways that we can't yet predict. We'll work within that for a while until somehow something doesn't work right. Then somebody smart will see, maybe if we think about it this way, we'll shift. And that will require people and communities, as you say, to make that happen. But it's sort of this notion that we don't. MIT students shouldn't show up and say, everybody that professors know at MIT, here's all the truths, and they're going to teach them to us, and then we'll go forth and we'll know it. No, it's the process of discovering truth, and how do we approximate? How do we even know we're getting closer? What do we even choose to measure? Is this sort of social part of that as well?
Right. So really, you want to, maybe it's not completely clear what this notion of getting closer to the truth amounts to, but what you fundamentally want to say is that our theory is just much more predictive and much more useful, and that's what scientific progress consists in, not in discovering the existence of oxygen or realizing that there's no such thing as phlogiston.
Building a model that includes one but not the other has then, in context with other assumptions, can lead to more predictive power. That's how I would put it. So I don't think those are just a linguistic difference, I think.
Right. Could I just ask you, just to go back to the claim about models? Sorry, what was the famous quote that models are always wrong? But
all models are wrong, but some are useful.
Okay, so someone might say, okay, what if by model you mean mathematical model? So we could have a mathematical model of the solar system, let's say, or a mathematical model of a neuron, or
it doesn't have to be mathematical.
No, it doesn't have to be mathematical, but just for simplicity, just take a mathematical model as an example. So we have a mathematical model of the solar system, and it makes certain simplifying assumptions to make the computations tractable. Maybe it treats the planets as point masses or something like that. So it's highly predictive. It enables you to predict where Neptune is going to be next year. But, it's not perfectly accurate. If we run the model out like billions of years or something, it's going to get something wrong. But for the purposes of flying by Neptune or getting to Mars or something, it's good enough. So in that sense, that model is wrong. And we understand why it's wrong. It's just like almost every mathematical model, it's just a simplification of the real situation. But that doesn't mean that we don't know anything about the actual situation that we are imperfectly modeling. We still know that there are planets and that they go around the sun, and that there's this massive object that we call Neptune and so on. So there could be some kind of mistake in focusing so much on the imperfections of models, because perhaps that can sort of blind you to the fact that, well, actually, we really are just flatly right about some things, like the approximate size of Jupiter, or the cause of the Great Red Spot, or something like that.
Well, I don't think I think the argument which Jim is making, which I resonate with, and Jim, tell me if I'm wrong. It's not a criticism to say all models are wrong. It's an acknowledgement that part of modeling is to understand where we made those assumptions and are they good enough for the predictions that we need to make. Right. So saying that all models are wrong is perfectly fine. Right? That's not saying science or engineering is bad. That is our framework that we need to make progress right now, and we need to understand the limits of that framework.
Right.
I agree.
Related to that, I wanted to go back. Jim also briefly said that part of this is getting comfortable with uncertainty, right? And I think one of the things, especially when I think about MIT students, these are students who have come in who have been terrific in physics, who've been terrific in math in high school, where there are absolute answers, right? You have a problem set, there's an answer that people are looking for. And then you get to college and, you realize, I've learned F equals ma. And then you learn, but wait a minute, actually it depends on your reference frame. And you learn about relativity. And then you read, but wait a minute, actually you shouldn't be thinking about things as particles. I should be thinking about them as probability distributions because now I've learned quantum. And so we keep, as you advance, you're actually starting to dismantle some of the things that you took to be absolute truths, even in science. And realizing that there are subtleties that have not been accounted for in the early parts of that journey.
Well, I completely agree with that, and getting comfortable with uncertainty.
So, well, just touching on that uncertainty point. I mean, how does that manifest in the classroom, if at all? Because after all, Pekko, as you were saying, I mean, this is a big difference between most of the classes that students at MIT take and their philosophy classes, for example. Sometimes I have actually given P-sets in philosophy classes, but the questions are all about, the reading or what some philosopher thought or whether some argument is valid. Those do seem to have clear answers, but they're not about like grand philosophical questions where there's a lot of disagreement. But of course, in most of the sciences, you've got your P-sets, and there's either a right or wrong answer. Grading them is totally straightforward. So, what do you do, or what could you do to make students aware that there's really a great deal of uncertainty in the scientific enterprise as a whole?
I think there are a bunch of tools that the students need to develop before they can start to apply them to these sort of bigger stories, right? So, before you can build a house, you need to know how to use a hammer and a screwdriver and a wrench and all of those kinds of things. And so there are tools that we are equipping them with, like how do you solve a linear differential equation? Is this thing going to be stable or unstable, right? And those are things where there's a logical progression. And so once you put things in these frameworks, you can get a sense of how you think these systems are going to evolve. So, but you have to be good at the tools. And the tools are things where you can assign a problem set, practice this a bunch of times, and you will now have the tool. As you move through your curriculum, I think in most departments, things become more and more open-ended. So, for example, right now I'm teaching the capstone in mechanical engineering, and this is a product development class. And one of the things they're thinking about now is feasibility studies. So if I have a product that I might want to design, and there's no right or wrong answer as to whether or not you should design this product, but you should check, okay, can I run this on a battery, or do I need to build a nuclear power station, right? And so you can start to apply those tools to understand, to kind of scope the problems that you're thinking about. And I think, and again, there's no right answer to that, but there's sort of a skill in how do you apply those tools that you've been developing early on.
Right. So just, I suppose, in a way, keeping the focus on the classroom. So sometimes people talk about the scientific method and laud the scientific method as a particularly reliable way of finding things out. And when I was an undergraduate, I studied physics as an undergraduate. And I don't remember having a class on the scientific method. No one ever taught me what it was. So do you think that there is such a thing as the scientific method? And if so, what is it? And do historians, for example, we have a historian here, employ the scientific method? So
I had reason, actually, for the Compass course to go back and, sort of look it up officially, right? The 5 steps, although it's 6 now because they've added persuasion and communication to the end, which is a good thing, right? But the first step was, to collect all your observations. I don't remember the exact words, right? And it really presumes a 0 step, if you will, that's not listed there. And that is that there are somehow unfiltered observations. And we've already, I think, agreed between us that doesn't exist in the world. And so that's a real problem for the scientific method, right? As a canned box. If it relies on, a prior step that can't be done, then it's a shaky foundation. That said, it's tremendously useful, I think, when students are learning tools, and maybe younger than college students, right? To, just sort of have a little list that they can follow, right? So I don't want to bash the scientific method, even though I don't believe in it.
I mean, it's one framework, but it's not the only framework that you would apply to advance knowledge, I would say. I'm going to now circle back, Alex, to you, because you originally came to were in the MIT mission statement, which is to advance knowledge.
That's right.
I mean, it's implicit in that we're not, that there's no end point here. Like to Jim's point, that to advance knowledge, that means there's more things to uncover, right? We're always peeling back more layers, which improve our understanding or improve our predictive power of the world.
So there are different ways of knowing.
Yeah.
Right. Excellent. Okay, so the mission statement does presuppose that all of us at MIT are really in the same business, at least at a certain high level of abstraction. We're all in the truth-knowledge business. We should be pursuing the truth or advancing knowledge in our different disciplines. Do you think that's right?
And to different ends.
Yeah. I'm not totally sure what the takeaway is.
Good luck, Alex.
Yeah, so it's hard to sum up this very wide-ranging discussion. So instead, I'll end with a completely different question, just to humanize the three of you, if you're not humanized enough already. So the question is, what artwork, whether that's a book or a piece of visual art or a musical composition or a poem or whatever, was your favorite or the thing that influenced you most in college?
This is going to be a somewhat long answer. So the first, when I got this question, the first thing I realized is that college was a really long time ago.
Yes,
I had to think pretty hard to figure out what I was doing in college. The second, once I started thinking about it, is that this is actually a very personal question, and so I will. If you answer honestly, you will learn a lot about us. So I will answer honestly. I'm going to give you just a few things. The first is when I was in college. That was when this amazing new technology came out called the musical CD, and so I got very excited about buying CDs, and it was also around the time that sort of like the alternative rock scene came out. So I think the CDs I listened to most were was probably Jane's Addiction, if I'm going to be honest, and Peter Gabriel. I have the whole Peter Gabriel collection. Then I was thinking, okay, what about books? Because I also did a lot of reading, and there's two that I remember from that time. One is a book called The River Why by David Duncan, and I'm from Oregon, so this was recommended to me by my friends in the Pacific Northwest. And again, I think it sort of fits with this podcast because it is about it's a coming of age and how to make choices about leading a good life. And the other one that I remember from college was A Canticle for Leibowitz by Herman Miller, which I randomly walked into a used bookstore and just picked it off the shelf, and it blew my mind. So those are the ones I'll contribute.
I'll start by saying that I grew up in a evangelical Christian family milieu with very thoughtful parents who were in the process of asking more complicated questions than the families that they had come out of. And when I got to college, I started reading theology sort of as a side project. And I actually was having trouble sort of thinking of any one particular influence, but it opened up a whole new world for me, in part because I discovered that people's religious beliefs had these deep histories that were complicated, right? And I think to some extent, both my parents are scientists, as are 3 of my 4 grandparents. And so, I'm the which one of these is not like the other in my family. And I think in part I became a historian because that was a way of thinking about theology without having to become a theologian. And I think my interest in the kinds of questions we've been talking about today came out of that.
Yeah, so the personal side of this for me is I was raised, like, my parents were both scientists also. My dad was a physicist, and they raised me in a Catholic family. And I remember hearing sermons about how evolution was impossible, and I was revolting at the time about going to college. And my book that I remember in college was Richard Dawkins' The Blind Watchmaker, which sort of explains how complexity could arise without a creator, right? And it's very convincing if you're into reading about evolution and how biologists think about that. And so reading that in parallel with looking at my other book I remember in college, is just this huge textbook tome of the, Principles of Neuroscience, which is essentially should be called the collection of facts about the brain, which are beautiful drawings of anatomy and look at all these complicated wiring systems. So juxtaposing those tomes of, well, here's all these wires, we don't actually know what they're doing, with these kind of, hey, some process has produced this that was, by selection. And there's an opportunity here that at some point we'll figure out who we are as a machine and understand what all those wires are doing. And that sort of inspired me to move on to sort of do this that I do now.
I also second what Pekka said about Peter Gabriel, early Genesis. You can't beat it.
Yeah.
Of course, no one listening to this podcast will have any idea what we're talking about.
Zero.
None
Yeah,
whatsoever.
exactly. Yeah.
I was busy listening to Bach and Palestrina in college.
Okay.
So,
Okay.
and I sadly haven't changed at all.
No, well, there is that sort of imprinting effect. There's Peter Gabriel, and I do remember reading Bertrand Russell's little introduction to philosophy called, which still can't be beat. It's flawed in so many ways, but it's certainly a gripping read, I think, to an undergraduate interested in the big questions. And that's his little book called The Problems of Philosophy. 1912, I think. Thank you so much. And Pekka, Jim, I really enjoyed the conversation, and I really appreciate you taking the time.
Thank you.
Thanks, Alex.
Thank you, Alex, for having us.
Thanks for listening to MIT Compass, thinking and talking about being human.
We hope you'll check out other episodes at compass.mit.edu.
This podcast was created as part of the MIT Compass Initiative, 2101, Love, Death, and Taxes.
This podcast was recorded at the MIT AV Studios
And produced by Adina Karp.